We're going to go over finding zeros for a polynomial. Now, you probably remember from factoring, when we factor x squared minus 25, that's called the product of the sum and difference. So that would just easily be factored. Remember, that's when you have, so x squared would be x and x, because x times x is x squared. Since that's a minus, one gets a plus, one gets a minus. What's the square root of 25? It's 5. So watch what happens. Let's work backwards. X times x is x squared. Outers are negative 5x. Inners are positive 5x. They cancel. And then positive 5 times negative 5 is negative 25. So we just checked ourselves, okay? So that factors easily. You could also, if I wanted you to factor and find your zeros, you would factor it and then set each of those equal to 0. Okay, subtract 5, so x equals negative 5, and then that comes out to be positive 5. You could also find your zeros by just setting that equal to 0. So you would add 25 to both sides. So you have x squared equals 25, and then you take the square root of it. So x equals square root of 25 is 5. But remember, if you personally put the square root onto your problem, you need your plus or minus in front. Because remember, negative 5 times negative 5 would give you 25. And positive 5 times positive 5 gives you 25. So your answer is actually 5 and negative 5. So don't forget that. A lot of people just say, oh, the square root of 25 is 5, and then they're done. No, it's plus or minus. Now, if you look at this one, it looks the same, except you have a positive here. Okay, so this does not factor. Can't factor it. There's no way you can do that. You can find your zeros, but they're not going to be real zeros. So let me show you what you can do. So what I'm saying is this has a case where you can break this down when it has a minus in between. If it has a plus in between, does not factor. So you're done. Now, if it said find your zeros, you would just take it, set it equal to 0. Now what happens? We subtract 25 from both sides. So we have x squared equals negative 25. And then we look and say, okay, well, I got to take the square root. But what's happening here? We're taking the square root of a negative number. And we learned before when we work with imaginary and complex numbers that when you take the square root of negative 25, this is not a real number. It means it's not one of your rational or irrational numbers or your natural numbers. It's going to be a complex imaginary number. This is purely imaginary because there's no real number with it. So when you take square root of it, you're going to have x equals plus or minus the square root of negative 25. Now we know what we can do. Remember, we learned before that if you have the square root of negative 1, you can use an I to replace that. So I can think about this as the square root of negative 1 times the square root of 25, because those two together make that. So I know that I can replace a negative 1, square root of negative 1, with an I. And the square root of 25 is a 5. And I can't forget my plus or minus in front. So this particular polynomial has two zeros, has 5i and negative 5i. So it has two non-real zeros. So your zeros could be real numbers like 5, negative 5, 1/2, negative 1/4. But you could also have non-real zeros. Okay. So let's look at this one. Let's set this. Oh, I got to make that a square. So let's set 4x squared plus 9 equals 0. All right. Because that doesn't factor. This does not factor. Okay. So the only thing you can do to find your zeros is set that equals 0. I'm going to subtract 9, subtract 9. So I have 4x squared equals negative 9. Okay. Now I need to divide by 4, so I have x squared equals negative 9 over 4. Square root. So I have x equals, I know I'm going to need my plus or minus. I know there's a negative in here, so I know I have an I. Now I'm going to basically simplify square root of 9 over the square root of 4. I just split them up. And that is 3/2. So you have 3/2 I and negative 3/2 I. Excuse me. And that is how you solve finding non-real numbers. Let's look at this next set right here. So if we're doing finding non-real zeros, what we can do right here is we could do you could do synthetic division. Remember, you could look at the last numbers and think of what are your factors of 36. So you could say, I'm going to factor by grouping. So I have a 1x to the 4th. I have no x cubed, so I have to put a 0 there. Then I have 13, and I have no x to the first power, so I have a 0. And then I have 36. And remember, the numbers I would try would be the factors of 36. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus 18, plus or minus 36. Or this factors, like this. It's a trinomial, but it's a power of 4, but that's okay. It's going to be x squared, because x squared times x squared is x to the 4th. And then I'm looking for two numbers that multiply to make 36. Well, there's a lot of ways to make 36. It could be 12 times 3, 9 times 4, 36 times 1, 36 times 1, and 2 times 18. Well, the combination that works where the two numbers add to make 13, because this is a plus, and that's a plus. That means it has to be plus plus. It has to be 9 and 4. So it factored. But now we're at that situation where these don't factor anymore, but I want to find my zeros. So you take that, set it equal to 0. Take that, set it equal to 0. Subtract 4, subtract 4. So I have x squared equals negative 4. Square root it, square root it. All right, I'm at that situation again where I have a negative inside of square root. So x is equal to plus or minus, the square root of 4 is 2. Since I have a negative, remember, square root of negative 1 can be replaced with an I. So it's easier to think about as 2i and negative 2i, because that's two zeros. Same thing's going to happen here. So I have x squared equals negative 9, square root it, square root it. I have x equals plus or minus the square root of negative 9, which is plus or minus 3i. So my zeros are 2i, negative 2i, 3i, negative 3i. So this has 4 zeros, but they're all non-real. Okay. So this will never cross the x-axis. This polynomial will turn, so it's a 4th power, so it's going to start up, finish up. So it's probably going to come down, turn, and then go back up. Or it could turn, go back up, but it's never going to cross over the x-axis. Okay? Now you can do the same thing here. Now this one we're going to have to do synthetic division. I'm going to come back to that. I'm going to do one of the other ones first. Let's do this one. So this one we can do factor by grouping. So what I can do is take out x squared, and I'm left with x minus 1. I can take out a 4, all right, and I'm left with x minus 1. See, these are the same. They always need to be the same if you're factor by grouping. See how they're identical? So you take that out. So they both have it, so you take it and put it out front. What am I left with? I'm left with my x squared plus 4. So what are my zeros? Okay, so that's factored completely, but what are my zeros? Well, if it's x minus 1, we know positive 1's a 0. And this one would be set it equal to 0. Okay, so as soon as you see that you're going to be taking the square root of a negative number, you should know that there's going to be an I involved. So it's 2i and negative 2i. So we have one real zero and two non-real zeros. Okay, now this one will factor like number 1. It's x to the 4th, so it's going to be x squared, because x squared times x squared is x to the 4th. I need two numbers that multiply to make 9, that add up to be 10, has to be 9 and 1. So I'm going to set that equal to 0. So I have x equals -1. Oh, x squared equals -1. So I have x equals plus or minus the square root of -1, which is just plus or minus I. So I and negative I are two of my zeros. We just solved this in one of the other problems, I believe. So we have x squared equals -9, x equals plus or minus 3i. So I have 3i and -3i. So we have 4 zeros, but they're all, none of those are real solutions. So this will not cross the x-axis. Okay, same thing here. Take out an x squared, I'm left with x minus 1. I can take out a 9, I'm left with x minus 1. X minus 1 is what I have in common, so I pull that out front. Very similar to this one up here. So I know 1 is my solution. We just solved this up here. So it's 3i, -3i. And that's how you do one like that. Now let's go down to here. This one, okay, I'm going to put my numbers down. Now, the number I try, remember, is my factors of 8, because this is a 1 in front. So this is just look at the back. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay? So there's a lot of different numbers you can try. I'm going to use a pencil first. Okay? So I'm going to try, you can try 1, -1. Let's try 2 for something different. Bring down your 1. 1 times 2 is 2. That's 0. 0 times 2 is 0. Add down -7. -7 times 2 is -14. Add down -16. That doesn't work. Let's see if -2 would have worked. Okay, sometimes it's trial and error. That's why I wanted to show you. Bring down the 1. 1 times that is -2. Add down, that's -4. -4 times that is 8. Add down 1. 1 times that is -2. Add down -4 times that is 8. Good. Worked. Got a 0 at the end. Perfect. Let's write it in since we know it definitely works. So that's one of my zeros. Since that worked, that's one of your zeros. Okay? So I brought down my 1. 1 times that was -2. That was -4. Always add down. That times that is 8. Add down 1. 1 times that is -2. Add down -4. That's 8. That's 0. We turn this back into a polynomial, or you can do synthetic again. It's up to you. I can turn this back into a polynomial. 1x, since that was an x to the 4th, we make this x to the 3rd, minus 4x squared plus x minus 4. So what can I take out of here? I can take an x squared out, and I'm left with x minus 4. I can take out a positive 1, because there's nothing you can take out, so you always put a 1 in front. Since there's nothing, since that's already simplified, you need a 1 as a placeholder there. So x minus 4 is what we have in common, and my leftovers go together. Okay, so if that is x minus 4, now since that worked, remember, x plus 2 was one of my factors as well. That's why -2 is a 0. Then this is a 4, and then I have to set this equal to 0. And I have x squared equals -1. I square root it. I have x equals plus or minus the square root of -1 is just I. So we have I and -I. So we have 2 real solutions and 2 imaginary or non-real solutions. And that's how you work with imaginary and non-real solutions.